Welcome to day 4, day 2, depending on when you showed up, of DevOps. This is Effective Service API Design. I am Elliotte Rusty Harold, and glad to see everybody this morning at 9:30. And, there we go. So why is this topic of interest to me? Currently, I'm tech lead of cloud tools for Eclipse at Google, which we'll be talking about more this afternoon. But before I did that, going back about 8 years now, my very first product at Google was what is now called the Analytics Reporting API, which was I hesitate to say the word web service, but it was an HTTP endpoint to which you could send requests using Java, JavaScript, or any form of HTTP library, and receive back XML that contains your Google Analytics data from your own websites and your own accounts. And you could organize it. You could use query strings to pull out different, subsets of your data, because most of us have huge amounts of analytics data, and you don't want to get that all at once. That's a subject we'll talk about. This particular product was incredibly successful, way more successful than any of us on the team had any idea in terms of how many people were going to use this, how much data we were going to have to transfer. It was one of those products that sort of came out of nowhere, and in terms of usage just skyrocketed once we launched it, way past anything we had planned for or expected. So I sort of said, this is interesting. We should pay more attention to these sorts of things. I will say I haven't been on that team for several years now. They're now on version 4, so various people, including Jacindra Soneja, multiple other engineers have been continuing that project for quite a while now, and it looks a lot different now than it did then. For instance, now the data you get out is JSON, not XML. That's a common feature of a lot of modern APIs in 2016, less common back in 2008, 2009 when we launched it. A little later on my next project, I call it redacted here. It's nothing super secret. It's just an internal corporate application at Google for managing internal, business things and people management and whatnot. Nothing we publish, nothing we really talk about. But it was something that was useful to expose the information in our local databases to other companies, other projects, other teams around the company working with that same data. And the way we did that is we built an API for it. In this case, this was based on JSON. It was based on some newer technology that was not available when I first did the Analytics Reporting API, and that moved along. I have also been on the other side of the API fence on many different projects where I have consumed APIs that are published by other teams, other companies, other projects. Currently, I'm working with various Google Cloud Platform APIs for managing Google Cloud Platform projects, because in the Eclipse plugin for working with Google Cloud stuff, we'd like to enable you to do things like create a new Google Cloud project, get a project ID, create a new database, etc., all from inside Eclipse. This isn't there yet. Don't go looking for it today. Look for it next year. But that's the sort of thing I'm thinking about right now. So what do I mean when I say an API? Technically, the acronym expands Application Programming Interface. It is we've had these, depending on what you mean by exactly, and we'll get into that, for at least 50 or 60 years. It's a means by which your code invokes functionality provided by other code, probably written by other people, other teams, other projects, other companies. And okay, those last 2 points shouldn't be there. So here's one example of an API I'm sure many of us have seen. This is part of the JDBC API that's part of the standard JDK, as seen in the API documentation or JavaDoc. This is the java.sql package. It lists all the classes, or at least all the public classes, and then if you drill down into it, you get all the various public methods your own code can invoke. You don't see everything. It's deliberately like an iceberg. It's showing you about 10% and hiding all the implementation details under this interface, and that's very important. Some classes, this will be true more in Java 9, make a bigger distinction between public and published APIs. Things that are not necessarily public, or that are public, may not be published and may not be available to use. But that's not too incredibly important for our talk today or in current work. That, however, is an example of a local library API, not a remote API, not a service API. The difference is critical to understand. If you're developing one, you're not trying to develop the other. And if you try and apply the lessons you've learned explicitly or implicitly about developing local library APIs, such as JDBC or Math.H and C or Microsoft Foundation classes. Do we still use that? Probably not in the .NET world, but it's been so long since I did Windows, I don't know. Those are local services running on a single computer, possibly replicated across many. That's not a remote API. That's not a service API. And if you try and make your service APIs look exactly like local APIs, you're going to get into trouble. So what is a remote API or a service API? I really want to try and use the two words there together rather than just API, because the single word just gets too confusing. It is a network service, almost always, not quite always a server, by which programs communicate with a bundle of functionality provided by code owned by someone else running on their computer, not yours. Okay? Cue Richard Stallman here. This is something you do need to consider when you're accessing an API, that you're tying your program pretty tightly to a service that may go away for any number of reasons. I know a number of developers who built products around the Twitter API, for example, have had some problems as Twitter's business model has changed, as they have changed the rules around what you can and cannot do with the feed that they provide, what they do and do not provide, etc., how much of it you can use. So you're putting some extra risk by using these things. Even if you're using an API purely within your company provided by one team, to your own team, what happens if that team gets destaffed? Do you have to take control of the API yourself? Can you do that? These are things to consider. Most importantly, I want to drill down into the I in API, because that stands for interface. And an interface, for our purposes, is an additional layer of indirection. It hides everything behind it, so that the client and the consumer of the API do not need to know, is it a SQL database on the back end? Is it a NoSQL database? Is it load balanced? Is it not load balanced? What is the data format things are stored in, etc. All a client should care about is the published, advertised API. And the rest of it is just hidden. That's really, really important. Now, in practice, that's sort of general. This can change. Today, in 2016, more often than not, it's going to be HTTP, or better yet, HTTPS. We should all be using SSL, and I know that I personally am not on some of my websites, and I really need to fix that, but for APIs, certainly. It uses as arguments, as input, URL paths, query strings, name value pairs, or I should say, JSON. Usually. You can send other formats, but that's more often than not what we have. And the responses usually come back in JSON, most likely. XML is still out there and still possible, works better for some use cases. And then in certain special cases, you may have JPEGs, PDFs, some other sort of weird binary format. But that's commonly how it works. Now, differences between local library APIs and remote service APIs. You need to keep this in mind. Not everything is different about them, but these really are. Number one, service APIs are fundamentally unreliable. just like any network program, just like any form of distributed computing. If you've ever encountered Peter Deutsch's 8 fallacies of distributed computing, they all apply here. The network is not homogeneous, the network is not reliable, etc. Unreliable. Networks fail. You just may not be able to connect to the service when you need to for any number of reasons, such as you're at a conference, you're on a Wi-Fi connection, and the Wi-Fi goes down. That's not going to happen if all the code is running on your laptop. The server may crash. The server may go down. The server may not be there. This happens. It may be overloaded. It may be slow to respond. That happens. So you need to worry about it. The vendor may decide to change the API, and then you have to update your code to match. Now, if you have a local library and Sun decides, or let's say more likely JUnit decides to change the signatures of some of the methods in the JUnit.jar file. Well, you can still use the old jar file. You don't have to upgrade until you're ready. By contrast, if Google deprecates version 1 of the Analytics Reporting API and says now you should be on version 2 of the Analytics Reporting API, and now instead of XML you're going to be getting JSON back, well, suddenly you've got a lot of work to do. And how much work you have to do may depend on their schedule, not yours. How much announcement do you get? This actually happened to the Google Eclipse plugin a couple of months back when we released version 3.9.5. The only reason that went out when it did was because one of the other teams at Google came to us and said, oh, this API you've been depending on for the last 4 years? We're turning it off at the end of the year. So you better migrate now. And suddenly we had to do a new version and a new release of a product that we weren't actually planning to do another release of ever. So that was all with APIs inside one company. So that's something to consider. If your code depends on somebody else's API, you need to maintain it. You need to be ready for these sorts of changes. Worse yet, you're using a vendor, they go out of business, or they just decide the API is no longer part of their business model. They're turning it off. It isn't there anymore. You can't use it. What do you do then? It's a risk. Service APIs tend to be slower than local APIs simply because of network round trip time, as well as having to execute across multiple computers. Better ones are faster, but it's never going to be as fast as the same algorithm. Well, I shouldn't say that. I mean, maybe in certain special cases like TensorFlow or something where the API itself is pulling together the power of thousands of computers in a data center, maybe then it'll be faster. Most of the time, though, it's not doing anything that complicated, and it doesn't work as quickly as your local stuff. If your API becomes part of an interactive application, i.e. there's a user sitting there waiting for things to happen and pressing buttons, then you're probably going to want to invoke it asynchronously and wait for the response to come back, because even if it's fast, most of the time it's not going to give you the sub-second response time you want. All of these are not really considerations if all you're doing is adding a jar file or a DLL to your project. A few examples of remote service APIs. I've already mentioned the Google Analytics Reporting API. Certainly I know the Google API is better just because that's where I live, but Microsoft has many. The Outlook REST API is an interesting one for reading your Outlook mail. Amazon seller accounts, many different APIs for managing which products you're putting up for sale, how things are selling, adding new products, removing them, changing prices, etc. Twitter has APIs that are probably not as public as I would like. You have to sort of sign up for them and get approval and have the appropriate developer keys and so forth, but they're there. IBM, I heard a couple of days ago talking about some of their Watson APIs for speech recognition and other products. In many cases, when you have services running in your cloud, like Watson, like TensorFlow, like Amazon seller accounts, there are many AWS APIs as well, and you want to expose them, this is simply the easiest way to do it, to let the world in and get some control over who's using it. So let's say you've decided to write a service API. So what comes next? What are the design considerations? I'm going to talk now mostly from the perspective of an implementer of an API rather than a consumer of an API. This is my single biggest takeaway of this session. So if you want to pull out your phone and take a picture of one slide, this is the one. Start with the documentation. Another way to think about it, start with the design. Think about what your API looks like. Do this before you worry about the implementation. You may already have a back-end service that you're exposing. For instance, in the case of Google Analytics, we had huge amounts of analytics reporting data in a data warehouse, custom built at Google. I don't want to tell you how big it is, but it's pretty damn big. And we were not going to expose all of that or necessarily in that format. The question is not what data do you have or what services do you have, it's what does the client want to do. So first think about the operations the client needs and then set up your endpoints that are going to support those operations. Then figure out how you're going to say, okay, well, we've said this is what the API looks like. Now, how do we connect it to our back end? What does that look like? Assume there's going to be some custom code in the middle. I would particularly avoid the anti-pattern, which is all too common, and I've seen it in more than just the API space. I've seen it in the database space and XML and a variety of other things, of some sort of data binding approach where you say, well, we have all these classes already, and let's sprinkle a few annotations through them or run some reflection code to just turn it into an API automatically. I think this requires some human intelligence and some human thought. You can use those tools if first you know what your API looks like, but don't start with them. Start assuming you're using HTTP. There are some other things out there like message buses, for example, things like PubSub and ActiveMQ, but I'm going to assume for right now it's more often than not HTTP. What are your URL paths? What do the query strings look like? What are the name value formats? What are the responses? Begin with your sample requests. What does somebody want to send? For example, for Google Analytics, maybe a very simple request would be, give me the hit count for this URL on my website. Or give me a list of all the pages on my website matched to the number of hits on that page on a certain date. Think about the queries the client is going to want to make, and then how can you reasonably incorporate those queries into, ideally, the URL itself, possibly including the query string component. If it's really complicated sometimes, then maybe you talk about request bodies and maybe you talk about a JSON format, if you need to. I wouldn't start there, but sometimes that's useful. Even more complicated, maybe you talk about sending XML, special use cases, maybe even you send binary data. Mostly, though, URLs work here. But where there's URLs or JSON or binary, focus on the requests and the responses the client needs first, even though you're implementing the server. Try and think like the client thinks. Try and think like what they're going to want to do. If we're doing a traditional library of local code and you write your code test first, then you're going to start by writing your API because that's what your tests are calling. We aren't writing necessarily tests first here. Maybe there's a way to do it. I haven't figured it out if there is. But it's the same sort of general principle. Start from the outside and work your way in rather than starting with the implementation on the inside and working your way out. That's going to give you, in the end, a much more usable API that clients are going to like a lot better. It may also be safer, too. There are some security implications. People often, if they just try and expose their data model, they expose too much, or they expose more than is needed. And then they have to have complicated whitelisting and blacklisting schemes. If you only ever build what you actually want to expose, it's like automatic whitelisting. Do not start with a schema, I would say. Think about the requests and the responses. Schemas can be useful for documentation in whatever schema language is appropriate. But again, don't start there. Start with the use cases. If you're going to write client library code, be it in Java, C#, Python, whatever, or back-end model code, that's later. First, start with the interface. And the interface usually is HTTP. I already said don't try to auto-generate an API. So that's my biggest recommendation for this, whatever language you're using, whatever tools you're using. Now, what do you put in the API? I'm a big fan of the minimum viable product. Start small and grow. In the case of that API for the corporate internal application, we started with a read-only approach to one table, essentially. We said, well, there's this data in this table, and that's the data we want to expose. That's what other people need. Now, once that was done, once that was out, that actually solved a lot of the use cases other teams in the company had. That was all they need. Not everybody's use case, not every team's use case, but some of them. And then we could say, okay, we've got table 1 done. Now let's do table 2. Now let's do table 3. Now let's think about how we're going to go from read-only to also allow people to write, which is a huge step, which is why I recommend starting with read-only first. Because it's simpler, it often has weaker authentication and authorization requirements. Sometimes, in our case, there were rules that were not implicit in the database in terms of how the different tables and fields had to line up. If you had this record in table A, you had to have that record in table B, but you couldn't just, the tables did not maintain that constraint. The application code needed to do it, so that was tricky. Again, read-only is a really good first step. You can push your API out there, you can get feedback. The beta version of the analytics reporting API, the very first one we did, we pushed it out there, it was useful, and we immediately saw we'd done it wrong. It was pretty clear in our case, we were exposing certain particular reports similar to the ones you could get by logging into the analytics website and looking at the standard web user interface. And we said, that's not what people really need. They need a lot more customization. And that was very clear as soon as we had launched. So we went back to the drawing board and we did a much more general purpose API. But we wouldn't have known that if we hadn't launched early with only a few of the reports we initially planned. If we had instead said, okay, we're going to take 2 years to write all the reports we think we need and then launch and then find out we're building the wrong product, well, that's 2 years of extra wasted time. So get as little as you can out there as fast as you can. See if people like it. See if the people you want to use it are using it. Collect the feedback. And again, read-only is a very good first step often. Third point, YAGNI. Who knows what YAGNI means? See a lot of hands going up. You ain't gonna need it. This is another reason to start small and grow. If you aren't sure if you're gonna need a particular piece of data in your API, don't put it there. If you aren't sure you're going to need pagination, well, maybe you need pagination, but if you don't know you need pagination, don't add it yet. It is always easier to add things to your API later than to remove them. Certainly anyone who's ever worked in Java knows this. How much deprecated stuff is there in Java 8 now that just sort of gets in our way and that still hasn't been taken out? I'm hearing rumors maybe in Java 9 they're finally going to actually start removing some of the things that were deprecated in Java 1.0.2. Who here remembers Java 1.0.2? Few hands. 1.0? 1.0 beta 1? Wow, am I the last hand up? I think I started with 1.0 alpha 3 if I'm not mistaken. Maybe alpha 2. It was one of those. But whatever you're doing in an API, people are depending on it. It is much easier to add things that are missing later than it is to remove things you don't want. So again, start small, leave things out. General design considerations. This is sort of assuming HTTP here, but that's probably where we are. Aim for single request, single response, no side effects, no ordering of calls. You can't always get this depending on what your API is doing. If it's read-only, it's pretty easy to do this. Once you have write APIs, once you have APIs feeding data in, okay, it's still pretty easy to do this. If you have APIs that actually commit to things, purchasing, manufacturing, it gets harder. But if you think about this up front, it's more often than not possible. The big fancy word for this is idempotent, which just means that if you send the same request twice, you get the same answer twice. It's the same as sending it once. That helps a lot with retries and failure modes. This is something clients are going to need to do a lot. They're going to send a request, and the request times out, or they don't get a response back. So they send it again. Meanwhile, the first request, especially if they're sending asynchronously, finally comes back. Now they've got 2 responses. What do you do? Your server-side API should be resistant to this. It should be perfectly okay if somebody gets the same data 3 times in a row or sends you the same record several times in a row. Generally, focus on the nouns. Think about your API as an interface to things, not actions. May or may not be true. You know, there are certainly APIs that can do things that amount to actions, you know, make a product, place an order, but even that, it would be more like create an order, focus on the order itself rather than the act of creation. Within HTTP, assuming that's what you're using, assuming you're not using something like PubSub, stick to your standard events. Get, put, post, delete. I'm not going to go into them in detail. Plenty of other, talks about that. They're fairly well known at this point. If you are careful and design up front and think about your API in these terms, you can usually get away with only these 4. The tough one is some sort of patch or merge operation. Sometimes that comes up when you want to update pieces of an object. Even there, more often than not, I find, if you find yourself needing that, means you haven't designed your URLs properly. One tip is you can have URLs both for things and parts of things. So if you have a person record, the person record may have name, social security number, address, etc. But the name of the person can have its own URL, and the address of the person can have its own URL, and the social security number of the person can have its own URL, and you can use those also. There is no rule that says each resource or each thing in your system has to have exactly one URL, or that you can't have sub-resources that somehow belong to another resource. So try and stick to your standard verbs where possible. This will make it a lot easier to implement on top of existing tools. It will make it a lot easier to handle load balancing and other nice features of the web. It will give you a lot of benefits of HTTP. So try and avoid custom verbs if you can. Let's see. Now, as part of the URLs, one way of thinking about them is endpoints. Be liberal in your use of URL paths. I often see people struggling to do things in query strings that become almost obvious if you use more of the path component of the URL. Try and avoid having a single path such as /call API or /soap where all calls go through. It's easier to split up a server that handles API calls across different machines if you need to, if different API calls are mapped to different paths. That's just how our infrastructure seems to work these days. Every resource is going to have at least one URL that independently identifies the resource. Not necessarily only one, but at least one. The resource of a URL is fixed and never changes. If the URL changes, that means you've got a new resource. What is a resource? It's what a URL identifies. What does a URL identify? A resource. Bit of a catch-22 there, but that is how it's defined. So try and keep your URLs consistent. The next point is officially against the rules, but I like it anyway. If you have meaningful names in your path components, human readable strings in English or whatever language, it makes development easier, it makes clients happier, even if technically URLs are supposed to be opaque strings. It's just easier to work with if you use the meaningful path components. Now, that's the URL. The next piece is the data formats. This is part of your API also. It's something we don't think about in a normal library API where it's all just ints and strings and objects and there are data types everywhere and it's all just passed back and forth on the stack or the heap sort of by magic. We don't have to think about it. When you're doing this remote API, a service API, you do have to think about it. This can be the data format for the client to the server, the request, or the server back to the client, the response. For server to client, generally JSON is good. It's simple, it's easy to process. There are a lot of libraries. There are some rough edges where the spec isn't actually defined very well, but you can usually work around that as long as you don't push the boundary conditions deliberately, as long as you specify that, yeah, we're going to send all our data in UTF-8, for example. If you need something a little better defined or something that supports somewhat more complex use cases, XML works very well. In special purposes, for instance, you're returning photographs or e-tickets for an airplane, a JPEG, a PDF, some other binary format. Usually I prefer text formats, again, unless it's something like audio, video, photograph. For everything else, text is just fine, whether it's JSON or XML or something else. All text should be in UTF-8. In 2016, there's little reason to use any other encoding. Certainly not for an API that's new that doesn't have legacy issues to deal with. So UTF-8, please. The storage format is not the exchange format. Whatever you're storing, just because you're storing data in JSON or XML or SQL database, or protobufs, that's another example, comes up a lot at Google, not so much outside of Google. That doesn't mean that's what you have to send to clients. That was actually a big decision we made back in the analytics reporting APIs days. One possibility was, well, let's just send everybody protobufs. Problem was, in 2008, even less so than today, no one outside Google knew what a protobuf was. So we sent them XML instead. Even though internally, guess what? Our data was all protobufs. We just translated it before we sent it. In general, this is important, this is often wrong. Data format should rule things in, not rule them out. They should say, this is what you can expect in a response, not, there will be nothing else in the response. You need to allow for future extensibility. Along these lines, schemas, be they for XML or JSON or databases, they should be documentation, not part of your processing chain. If you build them in, you make it inflexible, you make your system slow. Allow optional data. This is something it took Google, I don't know how long, 15 years to learn maybe, but in the latest style guide for protobufs in Proto 3, we say very strongly, don't make any fields required, ever. Just don't do it. It's still possible, but we really strongly recommend you not do it. This is what we're saying to ourselves internally. Because sooner or later, that required field, there's going to be a reason not to have it. It just makes life too difficult going forward. So don't make anything required. Try to make everything optional to the extent possible. Generally speaking, APIs, as I said, it's all text. Everything's a string. If you're going to have things like dates in your API, then use an ISO standard date format. If, for instance, for just a day, that would be something like 2016-11-10, year first, then month, then day. That's the ISO format. Ditto, there are formats for times. Use them. There are libraries to process these things in pretty much any standard language, so it just makes life easier for everybody. Numbers are trickier. I could give probably a 3-hour tutorial on number processing with floating point numbers and decimals and so forth, but I'll spare you. I would say integers, and be really careful about specifying what ranges people can expect. In particular, if you're promising that an int is always going to come in the range of a 32-bit signed int, say so. If you're not promising that, say that too. Similarly for real numbers, I would say just assume a decimal representation, and do use those words decimal, not floating point number. If it's scientific data, then you want to specify the precision, some other things. For most other purposes, you don't need that. For money, for instance, 2 significant digits is almost always exactly what you want. Try not to use the words double or float in your API because you're not actually sending doubles or floats, and the processing of those things is really, really wonky if you dig into it. That's a subject for another day. So just standard decimals. Okay, and I think that's what I want to say there. So that's your data formats. Now something else, very important for the people who are going to consume your APIs. How much can they trust you? What do you promise them? This isn't just about, this is what my response format looks like, and this is the name value pairs that you send me. But, you know, what's the service level agreement? Is this API going to go down? Can you take it down for maintenance? You know, how much response time can they expect? Is this going to respond within a minute? Is it going to respond within a second? Is it going to respond within an hour? That may depend on what it's doing. If you've got some really complicated speech recognition thing like Watson, it's doing offline, maybe that takes hours. Or maybe you want real time, you don't want to use that if you've got real-time responses because you've got somebody on the phone and you're trying to recognize their speech in your automated call response system. Then you need an API that promises we'll get your answer back within, 5 seconds or less, or 1 second or less ideally. Even more important than the response time, what's the deprecation policy? If the vendor of the API decides to change it, and they do all the time, we do, everybody does, it's just part of software development, are they going to keep the old API around until you get around to upgrading? How much notice will you get? 3 months notice is not very much, especially if you're the team that's working on your product that consumes this API has been de-staffed. 2 years notice is good. I have seen companies advertise 2-year deprecation promises, though they don't always keep them. So that's something you absolutely want to know before you commit your product to someone else's API. What are they promising? How much notice will you get? What if they're going to change the billing of it? Usually prices go down. Not always. I'm not talking much about billing in this. I don't have a huge amount of experience with that, but it is something to be concerned. What does the API cost, and can the cost change, and how much notice will you get if the cost does change? That's important. Generally speaking, as a developer of an API, not only do you need to define your deprecation schedule and get management to sign off on it up the chain so they know they're going to have to support this for a while, plan for versioning. Be ready if you're going to have version 2 of the API and version 1 of the API working at the same time. Think about that up front. Assume you will need to have multiple variants in production at once. If you do not have schemas, if you do have optional fields, this is easier because you can just throw extra data into your existing responses. You don't necessarily have to publish a completely new variant of the API. And then finally, another very important issue for clients and consumers, what's the lock-in? Will some other company, some other vendor implement this same API? If I decide that the IBM billing for the Watson speech recognition API is too onerous for whatever reason, I don't know if it is, I haven't looked at it myself, I'm just throwing that out as an example, then can I take my code and point it at someone else's server that is offering the same service at a cheaper price? Or just if a cheaper product come along without requiring me to rewrite my code? That's a very good question to ask, and it's not one I see a lot of API vendors answering up front or even necessarily thinking about before they launch. But it's also good for your own marketing if you can say, yeah, you're not locked into our product. We have to give you a good product and you have to use it because you like it and because we do it better than anyone else, not because there are no alternatives. It's the same value proposition of open source. It makes customers feel a lot more comfortable depending on you when they know there are alternatives. Sometimes in government contracts, this is a requirement. Okay, next point, next subject. Client libraries. Up till now, I've said, well, there's HTTP or maybe PubSub, there are clients connecting to it. We can connect to HTTP in anything, in Python, Java, C#, etc., Swift. But it is often useful and helpful to provide a classic API, i.e. an installed library, a local bundle of code that runs on people's own laptops or servers, that talks to your system, that abstracts away some of the details of the HTTP communication, the response processing, parsing the JSON or the XML, and the authentication authorization especially, because that's really complicated, and I'll get to that next. This is useful. It is not required. Do not assume that the people consuming your API will only use your client libraries to access this service. This is actually a mistake we made on V1 of the Analytics Reporting API. We sort of had in the back of our heads, yeah, we're going to support Java developers and JavaScript developers, and they're all going to use our client to talk to our API. And we made some decisions in terms of what we did and did not do based on the assumption they would use our libraries. Well, what about Perl? What about Python? I think we planned on Python support. We didn't get there while I was on the team. What about Go, which didn't exist at the time, or C#, etc.? I think we planned on C#. Again, took us a while. So provide client libraries to help your customers. Don't require them. Don't assume they will be used. Don't assume only the client libraries you write will be used. If you have a very successful API, other independent developers will also write and publish their own client libraries for your API. Doesn't happen a lot, but it does for some of the most popular. For instance, some of the Amazon Web Service APIs, there are 4 different client libraries to access those things, none of them official, none of them published by Amazon, and you can find these on GitHub. So provide them, but it's a separate effort. It's not required. It does not hide the fundamental unreliability of a network connection. So even if it looks like you're calling local code because you've got a local client library, it's still going out over the network. It still has to deal with timeouts, with server failures, with disconnects, etc. Still probably going to have a lot of asynchronicity built into it. And then the final point, when you're building a client library, this is something we've sort of learned at Google. Handcrafted is better than auto-generated. We don't really publish our own tools and libraries for building these sorts of APIs, but we're currently on, I believe, by my count, our 4th major complete different way of doing this since 2008. And the first 3 all were sort of auto-generated based on protobufs or based on code. And for the 4th one, they're just saying, nope, write it by hand. With some tools, with some support, with some help, but write it by hand. Think about it. You just get a better. Same reason you design your remote API by hand, because it's better. Same reason you design your local library API by hand, because you'll get a much better, more effective API. Decouple the API from the client. Do not, I already said this. Do not assume only the client you wrote will consume your API, not even if you don't publish your API. People sometimes find it. Servers in general should assume nothing about the client. Don't check referrer headers, for example. Don't assume it. This is a mistake we make inside Google a lot. We say, well, it's always going to be Chrome, because inside we use the Chrome browser. Well, no, actually. People do hit our internal services, other Googlers talking to purely internal things that have no interest to the outside world, like how do you schedule a vacation, will come in and use Firefox or Safari on their iPhone. So you've tried not to assume anything about the client. It's just HTTP. It's just standard stuff. Okay, authentication and authorization. This is the single hardest part in my experience of designing a web API that is anything other than read-only and open to the entire public, and anybody can grab as much as they like, which is rarely what you want, because even if the data is open to the world, there's still DOS issues to concern yourself with. Quick review, authentication, who are you? Who's calling the service? Authorization, what can this authenticated person do? Or what can this unauthenticated person, we don't know who they are, do? What resources are they allowed to have access to? And what operations can they perform on these resources? 2 separate questions. And then the third question, this is the one that has gotten wrong more than any other. Authentication is not what resource you want. Authorization is not what resource you want. That's in the URL. people get this wrong on the web all the time. An example would be almost any email provider you look at, where it will be www.example.com/mailbox. And that gives you completely different data depending on whether you're logged in as foo@example.com or bar@example.com. That's not right. Which resource you're going to, which data you're getting, should be purely defined by your URLs, never by your authorization or your authentication. I should be able to have a URL that points to your mailbox, but that doesn't mean I can see your mailbox if I'm not authorized to do so. And that has a lot of implications. It is true on the web and violated on the web all the time to bad effect. It is triply true when you're working with APIs. Do not confuse the authorization authentication with the resource. There are a number of different ways to do this. If you don't need two-factor authentication of some kind, basic over HTTPS still works. 20 years into the web. 25 years in? How long has it been? I'm not sure. But that's still pretty good, actually. If you need something beyond that, for instance, you need two-factor authentication, which for many applications is a really good idea these days. Try to piggyback on existing login systems if you can, rather than rolling your own, because they're really complicated, they're really hard to get right. Be that Google, Facebook, Twitter, whatever. Try not to re-implement this if you can possibly avoid it. If you have to, and use existing libraries to handle this because it's really complex. Three-legged OAuth, OpenID, JSON web tokens, we've had several talks about this week. These all solve slightly different problems. Use them if they solve your problem. Use the existing libraries. Don't try and implement this yourself. That way madness lies. Do not ask for more permissions than you need, especially if you're doing OAuth. Your API should require the minimum amount of permissions necessary. Just because I want to log into your service with Twitter doesn't mean I want to allow you to post to my Twitter feed. That's a common one. Or read my Gmail contacts or anything else. Leverage the existing flows in the browser, especially if you have two-factor authentication, especially where either you have to enter a code on a phone or receive a text message on a phone or press a little USB button stuck in the side of your laptop over here, whatever it may be. This is complicated. This is something we experienced recently in Cloud Tools for Eclipse. The old Google plugin for Eclipse just did did some things in an Eclipse browser window, but turned out that couldn't support the complicated two-factor authentication flows we're using today. So now instead we just launch Firefox or Chrome or whatever your installed browser is to do the authentication. Service and robot accounts. This is something you need to think about when you're handling authentication authorization. In many APIs, the things that are talking to your service are themselves services, or do not necessarily have a user handy. How do you deal with that? How do you make sure that they can log in? What credentials do they run as? Do you treat them differently? Do you recognize them as service and robot accounts? It's a hard problem, and a lot of the details of that are going to depend on what stack you're using on the back end to actually implement the API service. But think about it up front, because if you don't think about it up front, you're going to think about it later and it's going to get you. Developer keys. Authentication and authorization are about establishing who is communicating with your service. Developer keys, I wish you could do away with, but they seem too useful in practice. They're establishing which program is communicating with your service, who wrote it. So I, Elliotte Harold, may be using a program that was published by Twitter to access some other service somewhere else. And you want to know both things. One reason to use developer keys, for example, is let's suppose a third party writes a Twitter client that accesses the Twitter API and there's a bug in it. And suddenly it starts requerying way too fast and effectively DOSing Twitter. You may want to block all requests from that client. Now, that's not necessarily the same as blocking all requests from that user. You want to understand the difference there. This is a really hard problem. In my opinion, it's not a problem we've really solved. It does help you, if you have developers register, get a developer key, include that developer key in their application that they then distribute to users. It helps you identify the developers with good intentions, who aren't trying to deliberately break the system. It helps you avoid those sorts of accidental bugs where someone is DOSing your system. It does not stop bad actors. It does not stop people from accessing your API without registering for a developer key. All such things, kinds of developer keys, are trivially stealable. If they're in JavaScript, less than a minute, typically. You just pull someone else's Maps API key off their web page and use in your own program. Don't do that. I'm not telling you to do that, but it's doable. It's possible. And on the server side, you need to understand that people can and will do this. If you're really clever, maybe you can raise the bar to steal someone else's developer key from a minute to a day. If you're extremely clever. I'd be surprised if anybody could make it take longer than a day. So it's a bump in the road for API adoption. It will make it a little harder for people to use your service. Maybe you want that. Maybe you want to know who's signing up to access your API and write code against it. But if you can avoid using these things, do so. Performance considerations. For a lot of APIs, this is not as important as the performance of a web page because the program on the other end doesn't get bored, doesn't twiddle their fingers waiting for the page to load, unlike a real user. So a few seconds of latency may be perfectly acceptable. On the other hand, if one of the use cases of the API is there's a JavaScript program running on a web page, talking to the API, loading the data into the web page where a user will see it, then performance is a lot more important. If the response time is going to be on the order of 10 seconds or more, I'd say make sure you support asynchronous requests in your client library. If you have lots of data, use pagination. This is a common mistake I still see made today. I want to request all my page hits on each of my pages organized by day from January 1st, 2007 to December 31st, 2015. And oh yeah, I've got 1,000 pages. Now dump that all out. What are you going to do with that? If it's a batch job, maybe, but in general, paginate, especially if there's a user involved. Give them 10 hits at a time, ask them to come back for the next 10, or 100 at a time, come back for the next 100. This depends on the nature of the data, exactly where you cut your pages, but include continuation tokens. If you're using HTTP, don't try and optimize around the transport protocol. Let it do the work for you. For example, no custom binary formats, please. You don't need them. Use text. Let the gzip encoding on HTTP on most servers do the work. And that will reduce your bandwidth very close to optimal. Use keep alive in HTTP 1.1. Use batch methods in speedy/HTTP2. Use conditional get. Use last modified since, etc. All these sorts of nice tricks for playing with it. If you have good server libraries for implementing your API, if you have good client libraries for handling HTTP, this comes almost for free. You may not even need to think about it. Again, it depends a little bit on the library, especially for the newer, fancier stuff like batch methods in HTTP2. But mostly it's a question of reading the documentation and making sure you're using the right libraries there. And then life is really nice and simple. Rate limiting. Along with performance, clients can certainly DOS your APIs. This was certainly a concern for us on the analytics reporting API, still is, because a lot of data. And even somebody just wants to say, yeah, give me all my data for the last 10 years. Well, it's their data and we should give it to them, but it's going to take a while. So set this up, be it 10 queries per second, a total of 100 queries per minute, maximum whatever. Have sliding windows. Make sure you check this. This is where, if you can do it by user, good. That's a lot more secure. Use a developer key for this if you absolutely must, but watch out, it's forgeable. One thing that's new and nice is there is an HTTP status notification for this these days. It's 429. It says you're being rate limited. This is something we tried to wrap our heads around back in 2008 before this status code was conceived. And like, well, if someone's rate limit is at a 403, unauthorized, is it a 404, not found, is it a 503, server error? Now, there was nothing that really fit. The answer now is it's a 429. So use it. Okay, specs and tools to help you do this. I've talked about design, but when the code hits the keyboard, what do you use to write this stuff? Swagger in the Open APIs project are an interesting idea for documentation if you're using primarily JSON. If you're using XML or something else, not so much. But a lot of us are using JSON these days, so I would say worth a look. I would suggest design your URL structure outside of Swagger first by thinking about the use cases, thinking about what the client needs to do, and then document that in Swagger. Treat it as documentation, not as design. Again, I keep coming back to that theme. Frameworks and platforms for actually writing the code. There are many. These are just a few. Google Cloud Endpoints, Node.js, Apache Jersey, the Amazon API Gateway, Spring Boot Actuator, Spring Data REST, somebody did talk on yesterday, etc. There are a lot of these that can help you. I would just warn you, again, first design, then implement. So don't start here until you know what your API is roughly going to look like. Okay, final thoughts, and then we may have time for a couple of questions. Remember, remote APIs are very different from local library APIs. You cannot always assume things you know to be true about making a method invocation to be true about a network API. Like, it's going to return, it's not going to time out, it's not just going to fail silently. A network API might. A network API might change even though nothing in your own code has changed. Stick to standards like HTTP where they exist. Work with the stack rather than against it. Again, part of sticking with standards. Start small and grow. Think minimum viable products. Get something smaller out sooner and see what your clients think of it. And most importantly of all, do not let your implementation define your interface. The interface, the I in the API, that comes first. That is the first thing you design, and then you figure out, okay, we've got the interface here, we've got the back-end data and service over there. Most of the time that's done before the API is done. Now how are we going to connect the two? It's a question of connection, not of just exposing the back-end. So with that, I think we have time for one or two questions. This is not Jeopardy. You do not need to phrase your comment in the form of the question. You do not need to give a 2-minute rant and then say, what do you think about that at the end to turn into a question. So questions, thoughts, especially from the front of the room where I can see people? Yes.
Regarding pagination, how do you prevent handling duplicates to the client or skipping records if you go to the next page? So if the page boundaries change because the data changed.
Okay, the question is, regarding pagination, how do you handle page boundaries changing because the data is changing? This is going to depend to some extent on the nature of the data, to some extent on how the data is sorted, to some extent on what your back end looks like. You may, in some, not all cases, actually have the response stored and cached so that even if the data is changing, the response to the query is not changing. So even though 10 records have been added on the back end in the meantime since the second query comes in, those new 10 records are not included. Option 1. Option 2 is the IDs of the start and the end of the pagination do not necessarily have to be just indexes into a list. The start may be the URL of the first record, the end may be the URL of the last record, and it may even have a next link to the following record, which is then supplied as the continuation token. So there are a lot of different ways to do this. You do have to drill down into the specific nature of the data in the system, though. Yes?
You said we should aim for idempotency.
Right.
And how would we creation of the resource? How to prevent the creation of twice?
Okay, for idempotency, how to prevent the creation of a resource twice, this is exactly what put is for. Because if I send the data to create the same resource twice, the second resource with the same URL doesn't change anything. Assuming that I send a request to create John Smith as the name, and then I send the same request the second time to create John Smith again. That is, in a put request, the URL you're sending does not change. And it's recognized as the same resource and the same thing. That's the difference between a post request. Okay, I think we're out of time, but I'll be happy to hang out in the hallway if anyone has any further questions. Thank you.